enterprises. And he also a blogger. He wrote various blogs related to blockchain, GDPR, identity and access management, and microservices, security, etc. As we all know that now the enterprise API adoption has exceeded our expectation, right? So it's whether it's IT, OT, or ICT, on IoT, okay, countless devices communicate each other with APIs. Now the world is more connected than ever. Millions or billions or trillions of devices are communicating each other using the API. And that exposure, it's also, leading a security risk also, because many APIs are exposed to the public, and it's prone to like exploiting the enterprise infrastructure. So now, in early 2000s, the hackers, they are exploiting the other computer systems or networks for fun or out of curiosity. Or later that changed that the thought to, the intention or the motivation for the financial gains. Okay, many companies experienced that they lost millions or billions of dollars every year because of these security breaches. Nowadays, it's again, it's like escalated. Like now we see the nation state sponsored hackers are using the exfiltration of data, or they are exploiting other countries' infrastructure for, for exploiting the data and all. Again, cyber terrorism is another risk. The supply chain finance, we didn't hear about that such a attack before in early 2000, but now we started reading about supply chain finance, supply chain attacks, all these kind of these, like the SolarWinds blast attack. So it's a human tend to ignore like security while we design or while we develop the software or APIs. Why? Because we need to meet the deadlines, or the promises needs to be kept. So what we do is, it's a human tend to ignore the security. But for example, a simple rate limiting on an API will guard us from a distributed denial of service attacks kind of stuff. So I'm giving all the floor to our guest, Prabath. Prabath, the stage is all yours, please.
Thanks, Mithun, for the great intro. Hope all of you can hear me well. And good morning, everyone. And thank you very much for joining in. And most importantly, hope all of you are doing great and staying safe. Yeah, and also thanks a lot for inviting me for this talk. So I authored few books, and these are the latest ones. So the OpenID Connect in Action is the latest book I'm working on. It's published by Manning, and early access edition is released, but the final version of the book will be released towards the end of this year. To set the expectations right, in this talk, I'll be mostly talking about how do you protect APIs and some of the architectural patterns. So most of the stuff are covered in the advanced API security book. Once again, I think as Midun said, like, so security is a broader domain. So there are a lot of challenges. So I will mostly focus on the authentication and authorization aspect of security, but beyond that, there are many spaces that we need to worry about when doing a security design for APIs. And also, I welcome questions at any point. So I'll be happy to make this very interactive. So if you have any questions, hope you can ask it from Zoom chat. Or else, like, I hope you can unmute and just ask the questions too. Is that okay, Midun?
Yeah, they can type their questions in the chat box, and the end of the session we'll find some time to answer all those questions, or the Q&A session.
Sure. Yeah. And also I'll be going a little like technical, but I'll try to find the balance. So if I'm like too much technical, please let me know.
Sure,
Yes.
Prabhat, go ahead.
So yeah, so let me start with a very simple example. I assume all of you are familiar with Facebook, and you have Facebook accounts, and probably you have used Facebook to log into third-party applications. It's a very common use case. So rather than creating your own set of credentials at a third-party web app, you can log into that third-party web app using Facebook. The way it happens is, or else let's say this particular third-party web application needs to publish or read your latest status message from your Facebook wall. Right? So Facebook has an API for that, but this third-party web application cannot directly talk to that API and read your status messages. It needs to get a token on behalf of you to access that API, right? So the way to get that token is, I'm sure you are familiar with this one. So when the third-party web app needs access to your API, it will redirect you to Facebook. That's the arrow one. Then Facebook will prompt you for authentication if you haven't logged in, and also it will show you that okay, this particular application wants to access your Facebook account. It needs to publish, or it needs to read uh, your latest status message from your Facebook wall. Should you allow? So if you say allow, okay, it's fine, let it read my status, then Facebook will return some kind of a token to this particular third-party application. And this token now at the third-party web app, it's only good enough to read the status from your Facebook wall. It cannot read your friend list. It cannot do status updates for you. It is only good enough for a given scope. So then in number 5, using that access token, this particular third-party web application can access the Facebook API and then read your status. So this is a very simple example. And also, it also demonstrates a very common pattern how you secure APIs on the web, right? So here, Facebook is the API, and also you can call this as a resource server, right? So Facebook server, it hosts set of resources. So those are the like you can think about, like if you go through the REST API definition, you can think about your Facebook wall, the friend list, your photos, all are resources that are stored in the Facebook server. And also Facebook is playing another role. It also acting as a token issuer. Also, you can call it an authorization server. So that issues a token in number 4 to the third party application, which is only good enough to access your good enough to access to read status from your Facebook wall. And if it tries to read your friend list, Facebook API will reject that. Right? This is a very practical example how Facebook works. Now, if we try to map this to O2O, I guess most of you heard of O2 and some of you are very much familiar with O2O. So O2 has become the de facto standard for securing APIs. Right? The way it works is, at a high level, O2O is an authorization framework. Right? So in computer terminology, when we say a framework, so it is an abstraction which let users to extend it and to build some user code. Right? So you can build stuff on top of a framework. So framework, it's not a concrete solution. So O2O is kind of a framework. So it has a lot of options. Then again, it's your responsibility to find how to use this O2O framework based on your use case. And apart from the O2O core RFC, which defines this framework, there are several other specifications, profiles that explains extend the O2O framework. So that in a way has made it a little complex to use. When you have so many choices, sometimes it's difficult to make the right decision. right? So OAuth 2.1, so which is going to be the successor of OAuth 2, it's still at the very early stages, is trying to address that. Okay, so in OAuth, it defines 4 characters. So think about this or map this to our Facebook example. There's an authorization server which issues tokens, then the resource server which hosts your resources, then the resource owner who owns the resources, and a client application which wants to access resources on behalf of the resource owner, right? In our previous example, if we try to map this to our previous example, so Facebook is playing dual roles. It also acts as an authorization server, also as a resource server. The first step is to access a resource. The resource is protected with OAuth. That means if you want to access this resource, you need to bring a token from the authorization server this resource server trusts, right? So now the first step in OAuth is you need to talk to the authorization server and get a token, right? So there are multiple phases involved in it. However, at high level, somehow you get a token. The way you get a token, a client application gets a token from the authorization server is defined as an grant type in OAuth, right? So there are multiple phases in a grant type, but as a whole, how you get a grant type, how you get a token from the authorization server to access a resource on behalf of the user is called a grant type in OAuth. So once you get a grant type, so there are multiple grant types, irrespective of the grant type, once you have a token, you can use that token to access a resource. Then the resource server will talk to the authorization server to validate the token. And if it is all good, it will let the client application access the resource on behalf of the resource owner. So that's how, at a high level, the OAuth framework works. If you have any questions, I can take them now, or we can wait till the end.
Yeah, I mean, we'll wait later.
Sure, yeah. So I mentioned that there are multiple grant types in OAuth, but the most common grant type is the authorization code grant type. So Facebook, login with Facebook, it uses the authorization grant type underneath. So this is how it works. I'll at a high level, I'll explain how it works. So this is the client application. So this can be a traditional web application. This can be a single page application, a native application, even a desktop application. So first, it will render the website on the browser, and when the user clicks on login, it will redirect the user to the authorization server. And in that request is called authorization request in OAuth.
Raghav, can you keep mute?
So the number one is called the authorization request in the authorization code grant type. And after that, number two, authorization server will prompt user authentication. So that's out of the OAuth specification. You can authenticate the user in any way you wish. And number three, user will submit the credentials. And number four, the browser will submit the credentials to the authorization server. So 2, 3, 4, all out of the OAuth protocol. The authorization server can implement in any way it wishes to authenticate the end user. So once that is done, in step 5, there will be a code, temporary code will be passed to the client application via the user agent or the browser. And number 5, you get that code, then the client application will talk to the token endpoint of the authorization server and exchange that to an access token. Now you have an access token following the authorization code grant type, and then you can use that to access an API, right? And then again, when you request a token in step 1, you need to specify, I need this token for this particular purpose. So let's say it's a customer's API, then you can say, I need this token to do a get to the customer's API. So when the authorization server issues a token, it will attach that token with a scope. That means when the client application uses that token to access the API, which is hosted in the resource server can check, or looking at the token can find out what's the scope attached to this token. If the token is issued to get customers, Then if the client application tries to do a post customers, then the resource server will reject it. So this is a very high level OU authorization code grant type. However, when you implement this in a secure manner, so there are things that you need to worry about. So O2.1 specification, it is very much like specific on this on the stuff. For example, if you implement O2 with native mobile applications or single page applications, in fact, any applications, today it's recommended to use Pixie or proof key for code exchange, another profile. So it helps you to fix the code authorization code interception attack. In O2.1 specification, the new one, it makes mandatory to use Pixie, and it's in fact part of the O2.1 specification itself. And also other parameters like how you use state parameter, even though in O2 state is an optional parameter, it's also recommended to use. So if you are more interested in like at the implementation stage, so have a look at the O2O security best practices RFC. So it defines set of best practices and best security patterns when you implement O2O for your web and mobile applications. So then the second grant type is client credential grant type. The first grant type is good if you have a system, web app, native app, any kind of an application which needs to access an API on behalf of an end user, right? So this grant type is good if there's no resource owner, or else the client application itself becomes a resource owner, right? Or in other words, this grant type is good if you want to do system to system authentications, right? For example, let's say you have a weather app, right? So you have a mobile weather application that needs to find, let's say, weather of or temperature or predictions, rain predictions, weather predictions of a given location. Then to get the weather predictions, you don't need to have another party involved, right? So the application itself can act as a system and authenticate to the authorization server, get a token, and use that token to access the weather API. So that system authentication, there's no third party involved, right? So if you have a user involved, third party user involved, and if your web app needs to access an API on behalf of the end user, then use authorization code grant type irrespective of the application type. And if you worry about a system authentication, then you can use client credentials grant type. O2, like if you have read through the O2 specification, it defines 4 grant types. So other two are password grant type and the implicit grant type. Both of them are no more recommended, and they've been removed from the O2.1 specification for very well-known reasons. Implicit grant type mostly it has many like security issues when you use it just as the just with O2 itself. So it's removed from the O2.1 specification. And password grant type is actually is doing the opposite of what O2 was originally designed. So O2 is about delegated authorization. But with password grant type, you are giving away your credentials directly to a web app. So only reason why it was included to the O2 specification was to help legacy applications which used basic authentication to authenticate users to migrate into O2 in phases. And both the grant types are now removed from O2.1 specification. So if you design any applications now, use authorization code grant type, irrespective of the application type. And if you worry about system authentication, then use client credentials grant type. Yeah, so this is a very common pattern in how you secure a set of APIs. So typically what happens is if you have microservice deployment, so you have all this microservice deployment, and then you can selectively expose a set of microservices to the outside world through an API gateway, right? You don't need to necessarily expose all the microservices. You can just say like, foo and bar microservices are exposed through the API gateway via APIs, and C microservice is just in internal microservice. So now here at the API gateway, you expose set of APIs, and we secure this layer with OAuth2. Right? Then these are the applications. They can be web applications, single page apps, and native mobile apps, or any kind of an application. And these applications can access these APIs just by being itself, or just acting as a system, or on behalf of a set of users. Right? So the pattern would be, so you have an identity provider. So these users will first authenticate to this IDP, this identity provider. This protocol can be either OpenID Connect or SAML. And then you get a token here. Then you pass this token along with the API to authenticate to the API gateway. And API gateway has to trust this particular IDP to accept the token. If it's all good, then you will route that particular request to the upstream microservices. So you need to worry about edge security at the API gateway, and also you need to worry about the inter-service communication. So this is known as north-south traffic, and this communication is known as east-west communication, right? And in addition to that, typically the gateway will worry about authentication, authorization, throttling, and gathering analytics of these APIs. And if you expose these APIs to the outside world, so there will be another gateway in front of this particular API gateway, which is called a web access firewall. So this web access firewall makes sure that the API layer is protected with DDoS attacks, and also it can scan messages for known issues. For example, if you look at OWASP top 10 API security vulnerabilities, so these WAF solutions will scan for those top 10 OWASP top 10 API security vulnerabilities, and if anything is found, will block the message at that level itself. So these are typical API deployment along with a set of microservices. Okay, so this is an extension of the previous pattern. In the previous pattern, you can see all the users are coming from the same identity provider that this gateway trusts, right? But it may not be like that, right? So these users may belong to a totally different domain. It can be your partners, right? So this is these are your APIs, right? And these can be these are your applications, right? And you want your partners to log into your applications, and then also to access APIs, right? So in that case, only way to authenticate the users coming from your partner is through their home IDP. So whenever you try to log into one of these applications, you will redirect them to their home IDP. It can be OpenID Connect or SAML. Then these applications will trust this particular IDP. Now you get a token, right? So if you're an OpenID Connect flow, you will get an ID token as well as an access token. And if you're new to OpenID Connect at a very high level, it's an identity layer built on top of OAuth2O. But you cannot use that access token as it is to access this gateway, because this gateway doesn't trust this particular ID. It only trusts its own IDP or its own secret token service. So this application has to do a token exchange, right? So you need to pass the token you got from this IDP to this particular secret token service. And it has to trust this particular IDP. And if it trusts that particular IDP, it will exchange that token to a new token and pass it to this particular application. And this application can use that token to access the APIs. And the API gateway, since it trusts this particular STS, it can validate the token, and the rest of the flow would be the same. Okay. So that's about the edge security. So edge security, we will mostly worry about securing APIs. Now let's move into the microservices layer. Typically what happens is, when the gateway authenticates a request, it identifies who the end user is, who the client application is. It will create some security context. right? And it will create some security context and pass that security context to these microservices. So this security context will include information about, details about the application, the user, maybe user attribute, some other metadata. So those data can be used by these upstream microservices to do access control. And the most common way of passing this metadata from the gateway to the upstream microservices is in the form of a JSON web token or a JWT, right? You can think about JWT as sort of a container which can be used to transmit set of claims or attributes in a cryptographically safe manner from one place to another place, right? So JWT is the common way of doing that. Okay, so now if you go to this model, so now the gateway will talk to the STS and validate the token and will send that JWT here, and that JWT will go to this particular microservice. Now if this microservice wants to talk to another microservice, now we need to worry about how do you secure this inter-service communication, service communication. The most common pattern we have seen is the trust the network pattern. So if you are behind the gateway, you don't worry about the authentication of the systems. You will simply, if you are inside the network, then you can simply talk with each other. But now this is known as an anti-pattern. The pattern we follow now is called the zero trust network pattern. So as the name implies, if you zero trust means you don't trust the network, right? So if you don't trust the network, then you need to make sure you do all the security validations as much as closer to the resource, right? So that means each microservice has to do a security check. You need to, each microservice should authenticate the user, authorize the user again. Now, so authentication is fine. Now, when it comes to authorization, typical environment, typical enterprise environment, you will have two places to enforce access control policies. One is at this gateway layer, like if you have an enterprise cost-and access control policies, you will enforce at the gateway level. Those are across all the microservices. But if you want to enforce certain access control policies, fine-grained access control policies by service, then you can enforce this at each microservice. So whenever a request hits a microservice, it will authorize a request, it will authenticate the request. Now, one improvement from the trust the network pattern is mTLS. So now you don't trust the network, you will enforce mutual TLS between microservices. So if you, so mutual TLS means it's secured with certificates. So if this microservice wants to talk to this microservice, right, it has to trust the issuer of the certificate of this particular microservice. Typically, for a given deployment or a segment of microservices, so there will be a single issuer of the certificate. So they all trust the single issuer. So if any of these microservices has a certificate issued from that particular CA, certificate authority, then you will let the communication between microservices happen, right? So to use mTLS. But once again, mTLS is used for system authentication, and still you will be using a JWT to transfer the end user context, right? So along with this mTLS, you will pass a JWT. So that is this pattern with a shared JWT, right? So you get a JWT here, which which embeds the user information, application information, and other data, metadata, and it will be passed the first microservice. And when the first microservice talks to the second microservice, it will also pass that particular JWT along with the mTLS. But this has one issue, right? So this is secure, and this seems to be the very good first step, right? You use JWT to securely pass a user context between microservices, and you use mTLS for service authentication. So this is a very good pattern. But one issue here is when you get a JWT, it has a parameter called audience, right? So audience means this JWT is good enough to access a microservice with this particular audience, right? Now, if you are going to use same JWT across multiple microservices, then all of them have to share the same audience, right? So if you pass this JWT here, it will accept it because it checks it against an audience value known to it. And when you pass this to other microservice, it will also accept it because it has the same audience value. So you are basically passing the same JWT. But the issue here is a JWT can also carry information which may need not to be shared between all the microservices same level, right? JWT can define what this particular user can do on a given microservice. So it's always better if you can have a JWT which is specific to a given microservice. And this is how you do that. You do a token exchange. So you get a JWT here, the first JWT goes to the first microservice. Then before the first microservice talks to the second microservice, it will talk to the STS, pass the JWT it got from the gateway, and it will exchange a new JWT, and new JWT will carry a new audience value as well as new set of scopes, and this microservice can use JWT or mTLS to access this second microservice. Is a very much like improvement from the previous pattern. Now the question is, how do we implement this? Right? So when you build microservices, do we need to implement all these validations like mTLS validation, JWT validation, all at the microservice? If you do that, then you basically violate the single responsibility principle of microservice. So you don't need to actually worry about the security stuff. You think about your business problem and you build a microservice, then you can use a proxy in front of your microservice to do all these security checks. Right. So this pattern actually you may have already heard of, called like service mesh pattern. So each microservice will have its proxy sitting in front, and if you use Spring Boot, you may know Spring Boot has a set of handlers, right? So in that case, its proxy is embedded into your microservice. It has its own disadvantages too. Or else you can have your microservice running in one process and the proxy running as another process. But at the network layer, you can say only way to access this particular microservice is by going through this proxy. Typically, you would do that through updating the IP tables of that particular node to make sure none of the outside traffic can go to this microservice without going through the proxy. All the inbound and outbound traffic to the microservice will go to the proxy, and the proxy will do JWT and mTLS validation. And also you can enforce fine-grained access control policies at the proxy layer. So the microservice developer, they can only worry about the business logic. They don't need to worry about handling complex secret stuff. And once again, there are common proxies. If you use Istio as a service mesh implementation, then Envoy is being used as a proxy. And so there are other popular service implementations as well. And then again, so another pattern here is, so here you can see there's a proxy in front of all the microservices. Another extension of this pattern is if you want to group set of microservices, then you have another gateway here. It's called a micro gateway. So you will have like 3 microservices, which is fronted by one micro gateway, another set of microservices, which is fronted by another micro gateway. So the communication among microservices which are behind one micro gateway can happen directly. But if you want to talk from one microservice to another microservice behind another micro gateway, then it has to go through that particular micro gateway. This is important if you have different governance model. Like, so it can be governance model or trust models, right? So if you have one department, if it has its own proxies, it has its own microservices, then you can have a micro gateway to have a clear trust boundary for those microservices. It's another advanced pattern, but we see at enterprise level that is being used as well. So that's what I plan to cover. Probably like we can take any questions now.
Hello.
Yeah.
Yeah. Hi, Prabath. Yours here.
Hi, Ray.
So first thing first, I want to say kudos for your book. I purchased it on Amazon 2 days ago, and I've been reading it, and I think that's not just a good book, but also pretty interesting to read because it's not boring, you know. It's
Thank
pretty
you.
interesting. So actually, from my side, as the best practices that I have for now so far is when we are talking about the API security, basically, I will imagine that actually the API lifecycle management is the pretty important things to manage, right? That's the first thing, and also the OAuth for the public facing APIs. And as you mentioned just now, for the internal communication, we need to have the mutual TLS in order to secure the communication happens between two or more parties inside the ecosystem. And I have one curiosity here about the social engineering attack. So because I read some part of the book on in your book that some shock story about I think Holland, right? Holland when his identity being attacked by some attacker, and so the attackers got the Twitter's account and so on, Instagram, so on and so forth. But
Yeah.
that's can be considered a social engineering attack that it's beyond our scope in terms of the application development and infrastructure as well, right? So how do we handle this kind of social engineering attack?
Yes, I think that's really hard, right? Even if you heard of the recent attack on Twitter, right? So how they managed to get access to an internal Twitter tool, support is used by Twitter employees, and then people were able to tweet from like Bill Gates and other like celebrities to popularize a Bitcoin scam, right? So that happened once again through a social engineering attack. So they were able to get credentials of a support engineer at Twitter and use that credentials to access that Twitter admin tool, which has access to all the Twitter accounts, right? Uh, so that's why it's also commonly known as the weakest link in the security is this human being, and that's why people use that social engineering. So one way is education, but once again, even if you know stuff, right? Like Aadhaar, for example, India, right? So sometime back, one of the journalists, they gave $50 or 50 rupees to someone and was able to get their Aadhaar, like it's an employee, get the Aadhaar credentials. So with that, they had access to the Aadhaar system. And also, I read a story some time back. It's a financial like institute in UK. So they were able to bribe an employee with £50 or something and get access to these employee accounts, right? Uh, so it's really hard. One way to do that is have proper audit logs, and then and use machine learning stuff, even though the credentials are being leaked. So machine learning systems to some level will be able to generate events if they find like anomalous behaviors in accessing, right? For example, if a banking employee, right, he may not access all the employees, right, within, let's say, like 500 employees within 1 hour. But when an attacker gets access to his credentials, right, then they may attack all the employees, right? So it's an anomalous behavior. So even though credentials are leaked, so if you use machine learning AI, then those things can be detected. And then the other stuff too, like so MFA to some extent, but once again, social engineering, it's hard. But from the end user's point of view, right, it's always better to use MFA. In this particular example you mentioned, right? So they were like the attacker first talked to Amazon, and then through Amazon they somehow been able to get the credit card information or something, and then looking at the domain, and to get that credit card information from Amazon, the attacker wanted to know his mail address. So he picked the mail address from the domain registration. So domain registration, it listed out the mail address, and used that and got access, was able to recover the account, like reset the password, right? So if you have used like MFA to some extent, you can reduce it, but once again, it's hard. Like you can, like if you are really good, right? In tricking people, still you can get that particular person to reset the MFA options too. So one option usually the attackers look at is this recovery path. So if you develop something, you need to make that very strong, right? And from the end user's point of view, always use MFA. So when you use MFA, you can restrict the account compromise to like 99%, right? So if you use MFA, the account compromise will be reduced by 99%. So there's a big chance, but people like still reluctant to use MFA. So there are multiple ways. It's very tricky once again. Yes, so education itself is not enough.
Got it. Oh yeah, one more question, please. And also, when we trying to increase the security level, especially from the application perspective, right? Sometimes we need to also make sure that we preserve the user comfortable zone, right? Because let's say if, as you mentioned in the book, let's say the password is too long, or probably I can say that sometimes, as for me, I'm not comfortable to change the password, but when I try to change the password, I cannot use the old password. So what would be the practice in this case? Is it something that we need to also discuss with the management, and let the management decide about the SOP and so on, or is there some best practice that we can follow in this particular case?
Yeah, so even if you read this NIST specification from the US, so they also have like their thoughts on this one. So if you have these complex policies, right, and if you ask users to change the password very frequently, they will start to find shortcuts, right? So if they may use the same password for all the services because they can't remember multiple complex passwords. Or else, like some people, of course, they'll use password managers, but some may like common public, right? So they may write down the passwords, right? So don't try to make that complex, right? Always try to go with the MFA. So you have the password, so it's strong enough to some extent. Use MFA. So MFA will reduce attacks, as I said before, by 99.9%. So rather than focusing on very complex password validation rules, enforce MFA.
Okay, cool. Yeah, yeah, thank you.
Hi, Prabath. This is Sham here.
Hi, Sham.
Prabath, in the recent slide, we see that the API gateway that sits on the top of microservices. So when we implement on microservices and domain-driven design, the services are distributed. So having one single API gateway and an identity provider over all these microservices, will that still not be a single point of failure?
That's right. Yeah. So that's where this micro gateway concept comes in, right? So when you do the domain-driven design, when you group together, you can create trust boundaries around that. So then there'll be a micro gateway in front of those microservices, and there's another gateway, this corporate gateway here. So you can enforce policies at different layers.
Nice. So similar to this API gateway, we also have this message validation, which is the web application firewall that sits over. So typically in the gateway pattern, so we have this web application firewall. Behind that, we have this API gateway, and this web application firewall is trained every time when a new services get added. Is that not adding complexity to bringing up new service, or is there any alternate addressing this problem, not having web application firewall at the top?
So once again, so web application firewalls, they also act as like so API gateways, but it's two responsibilities. So I think web application has to in front of should sit in front of the API gateway, and rather than having like if you are exposing your APIs over the internet, then rather than having your own on-prem web access firewall, you can go for something like Imperva, or like if you're in Amazon, so they have their own web access firewall, because like to block traffic, just looking at your traffic, local traffic is not enough. So when you as a service So they will learn from all their consumers. So based on that, they know like how to blacklist IPs and learn from different attacks. So anything internet facing, I think today should go through like global WoW solution, which sits in front of your gateway, the API gateway.
Okay. So again, my next question is on the microservices and distributed. When a user is using a couple of services, maybe I'll take one as a customer, and he uses some payments messages, and he takes a different role in these two domains. So for a user, there are different roles and policies that are applied in two different domains. Should this be handled at the identity layer, or it should be within the microservices itself?
It should be within the microservice itself. So here at the proxy layer, you can enforce it, right? Then also you can have a decentralized policy decision points, right? So ideally, like in the service mesh pattern, what happens is this particular PDP itself will be embedded in this proxy.
Okay.
Right? So you won't do a remote call to do an authorization check, and you will have some kind of policy distribution model to push these policies to the particular proxy. One is it can be an event driven, right? So you can have set of PDPs, and these guys will be listening to specific topics. So whenever there's an update, they will pull the relevant policy to the proxy. Yeah, so you can have like common policies centrally, and then service specific policies at the proxy level. So have a look at OPA. Like I guess you may be already like familiar with OPA, Open Policy Agent. It has become one of the very popular tools to define these access control policies in this cloud native world.
Thank you. I'll just read a couple of questions which is popped out in the chat also. Can we use site proxy like Envoy within our data pipeline?
Yes, you can do that. So when you say data pipeline, like what does it really mean? So basically, Envoy proxy will intercept traffic coming to you, right? So it supports gRPC and TCP, HTTP, and see the protocol supported by it. So if it is applicable to you, of course, you can use it as an interceptor.
Okay. It's data plane, not data pipeline. Sorry.
Okay, data plane. Yes. So basically, what you see is a data plane. So proxy always in the data plane.
Okay. One more.
So Prabath, yeah, sure.
Yeah.
Hi, Prabath. So my question was like, can this proxy be made as a library so that it can be used with every other microservice? So the logic inside this proxy will remain the same for all other microservices. No? So can it be like that, and we can include this library in all other microservices?
Yeah, you can do that too. Like so that is called the embedded service mesh pattern, right? So you still decouple it from the business logic as a library, then you embed it in the microservice. So it's still a service mesh pattern, but it has its own disadvantages. So one thing is it's language dependent. Like, so if you have multiple different microservices written in multiple languages, then you need to have that library written in different languages. And also, if you find any issue in that particular microservice, sorry, in that particular the component library, then you need to change, like you need to redeploy the complete microservice. And also, if there are changes in this the SDK, how you bind that library to your microservice, still you need to change. So basically, you couple it together. But when you run it at a proxy, those are the out of process service mesh pattern, which is the common one today with Istio and other the service mesh implementations. So that takes out all the challenges I mentioned before. Like they can act independently, they can manage, govern independently.
Okay.
So if you take Spring Boot, Spring Boot follows this embedded service mesh pattern. So there are set of libraries. You just need to add the dependency to that, and it'll act as an interceptor.
Yeah. Okay. That was clear.
Hello. Uh, Sorry, I have one question again. So actually, part of the Trinity trouble that you mentioned on the book is one of it is the extensibility, right? And I think when we use the open source a lot inside the project, sometimes the problem is inside the library or the anything that we took from the outside, right? So is there any better way for us, probably some best practices, how to check the library that we are using inside the project?
So it depends like what tools you use. So if it is like if you develop an application, if you embed libraries, then during the build process you need to do like proper security screening. So there are tools, they will look for the known vulnerabilities, and they will check whether the dependency, basically dependency checker, it's a Maven plugin in Java world. I'm sure there are similar stuff in other languages too. See whether there are known vulnerabilities for those libraries, and then inform you. And another thing we see is these containers, right? So you download any Docker image, so that can introduce security vulnerabilities. So once again, you need to do proper tools like Docker Bench and those stuff, and do proper security screening. So security screening has to be part of your CI/CD pipeline. It has to be integrated with your build process to make sure that your build is secure from those issues. And also there are best practices, like if you use containers, Docker, rather than getting the latest version, go for a fixed one. And how you pull image, so you need to follow those practices, best practices.
Okay, cool.
Okay, one more question on the chat. From your experience, is it recommended to have an in-house identity provider platform, or should we go for a public ID providers?
Yeah, so it depends. It depends on your use cases. At WSO2, so what we have is on-prem IDP, and so we are working on our cloud deployment. It depends on the use cases. Some people who are very much worried about their data residency, and also when you want to do complex integrations, and you need to like customize the IDP, then you will go for on-prem product. But the trend is most people now, so they go for cloud. So think about what you have. Like I think the cost once again, and then again security. I think the trend is like moving to cloud. So if your use cases are straightforward, yeah, so start with cloud.
Okay. So another interesting question is, when can we expect OAuth 2.1 in GA?
I don't know so when that will be, but the discussion is going on. It's very actively discussed. I'm not pretty sure about the timeline, but once again, so OAuth 2.1 is not a major change, right? It basically built on top of OAuth 2.0. It builds set of existing profiles. Like for example, Pixie is already there with OAuth 2, but in OAuth 2.1 specification, it makes it mandatory, right? And it also brings in best practices which are defined in other RFCs to the OAuth 2.1 specification, and it removes the password grant type and the implicit grant type flows. So those are the major changes OAuth 2.1 makes. So in a way, you can think about OAuth 2.1 is how you use OAuth 2.0 securely, right? But now if you want to use OAuth 2.0 securely, you need to read a lot, and you need to know a lot about that, right? But you need to look for multiple references. But with OAuth 2.1, you only need to look at that particular RFC, and they are very straightforward and directly define the spec itself. So it makes the developer's life easier. It is not incompatible like if you use OAuth 2.0 in SQL today, so it's just like OAuth 2.1. Like if you use Pixie with authorization code grant type, and there are some validation rules in redirect URI, but once again, those are the best practices even today. So you don't need to look at OAuth 2.1 as a major change. It's a better way of, the secure way of using OAuth 2.0.
Yeah, happy to know that we are not outdated still. Okay.
Yeah. So your applications won't be like isolated. Anyway, like try to get it. If you're using implicit grant type, try to get rid of that, and parser grant type, try to get rid of that. Other than that, it's basically what you have today, but it's well defined to use it in a secure manner.
Yep. Right. One more question is it always preferred to prompt the credentials by the authorization server, or can the client application collect on behalf and share with the authorization server to claim the token? I think that is answered on the
Yeah,
second
so that's a
grant.
parser grant type if they like if you use OAuth, but that's not recommended. But once again, when you say it's not recommended, right? It's the common way, right? So at a common level, but if you can avoid that, but let's say you have in the same trust domain, I'm not once again recommending, but once again evaluate it against your use cases. Some people use that, but something you should avoid, should not something you should consider first place. But under certain constraints, like if it's a mass, knowing the risk, evaluating the risk, you can make a design, you can make a decision.
Right, right. How secure the token itself? Can anyone capture the token in between the transaction?
Yes. So OAuth 2.0, like in most of the implementations, they are bearer tokens. So bearer tokens are like cash. Like, so if I steal $10 from you, I can buy, I can use that $10 to buy a coffee from any Starbucks, right? So no one will like question me how I got that $10, right? So the bearer tokens are like that. So if I steal a token, I can use it anywhere. The opposite is proof of possession token. So they are like credit cards. So if I steal your credit card, when I'm going to use it, I need to prove that I own that credit card by signing it. So bearer tokens can be stolen. So then that's why you must use bearer tokens over TLS. So that's one protection. The other one is think about the expiration time. So if you lose a bearer token, you minimize the impact of that. And other one is when, if you go back to this diagram, the first one, here. So this is the flow, right? So this is the place the application passes this access token to access an API, right? So this should be protected by TLS. But once again, like so there have been a lot of like vulnerabilities reported on like TLS implementations. So you need to have like defense in depth. One additional step is you can enable mTLS between this and gateway 2. So in that case, even if someone steals a token, they won't be able to use it because that token is issued to this particular client. And if this client uses that token, it has to authenticate with mTLS. So that means you need to know the private key of this particular client. So even if a third party steals that, you cannot use that. So it has been a best practice over the time. You also do mTLS protection between the client and the resource server when you pass an access token.
Okay, okay. So one more question: Can an access token be restricted to an IP when it is generated?
Yeah, so you can do that, right? So when you so once again, how you find the IP is a problem. Like for example, if you have a website, right? So let's say it's a single page application, right? So if it's a single page application, and now you get redirected to the IDP. Now you know the client IP, right? So then you can bind that access token to that particular IDP. So it can be done through scopes, right? Scope can be associated policy. It can be anything like the resource server can interpret it in any way you can associate an IP. Now when a single page is the API, same IP, right? So then when you validate at the gateway, you retrieve the the IP associated with that token, it is part of the scope. So when you introspect the token by token to the IDP, it return back the IP because it's part of the scope. And then you can do the validation. Or else, other one is self-contained access tokens. It's opposite to the reference token. So if you have a reference token, then the gateway always needs to talk to the STS to validate token. If it's self-contained token, then the gateway itself can validate it. So IP or the scope can be embedded in JWT. Then the gateway can validate it. But once again, IP-based validations that can be like fooled by the clever attackers.
Yeah,
Yes.
but Mithun here again.
Yeah.
I got a tricky question from the business. Okay, what they were asking is like when a regulator says or sees the DR, I mean, from their perspective, it should be in another country or a different seismic location, something like that, a separate data center itself. But when it comes to the microservices, when it's the design phase, okay, the availability, scalability, and geospanning is already taken care. So how do we convince the regulators? Any thought process?
Convince regulators on what?
On the BCP.
Sorry?
On the availability or the BCP.
Okay. Yes. Yeah. So to convince that is like it's the we need to see the impact on business, right? So that's where some people even worrying about this. So people started worrying about multi-regional deployments, right? So they have their DRs running on different regions, and then now with this, everyone is going to cloud. They are also worrying about this multi-cloud deployments. So it's not just a region, but entire cloud provider can go down. So that has happened, right? So AWS went down some time back. So entire region or multiple regions went down, and Netflix and many other services who relied on AWS, they were down for some time. Even Google was down, right? Recently, for few minutes.
Yeah, their deployment went wrong.
Down.
Yes.
So once again, sometimes for small businesses, so there's no option. So it's an economic decision that you need to make, right? So how much you need to spend over the impact of such a incident, right? So it's an economic decision you need to make. If it is too costly, then people don't worry, so they'll accept the impact. But when it's highly critical business operations, then you need to worry about DR. But once again, you can think about different layers too, right? So of course you need to do this the failover setup. It can be in the same data center or multiple data centers. It's always better to go multiple data centers. Then the next level is multi-regional, and the other level is multi-cloud. So it depends on the business impact and the value of your business.
Thank you, Prabhat. Thank you.
Yeah, Prabath, this is Joseph. That's been a great session. One thing, we've been actively exploring WSO2, right? And now we have, when it comes to identity provider, we have many identity providers as a service. So the thought is like, whether to get into something which we don't know and, put our resources in managing that, or go for services like WSO2, get the thing on premises or on cloud and build the whole thing. For company size like us, like we are a financial services company, where focuses on building customer experience, right? So what would be the right approach for us? We go for a third-party identity provider or go in for solutions like WSO2 and build it?
Yeah, so one advantage of going for a open source, so once again, right, so my response can be biased, but I'll try to be not biased as much as possible, right? So one advantage of an open source on-prem IDP, you have more control, right? So what we see is many companies who move into cloud, so they still have sort of legacy data, and especially this in CIM space, you need to do complex integration. So most of the identity server deployments, I would say 90% of WSO2 identity server deployments, we have done some sort of extensions, like we have done complex integrations, which may be a little hard to do with the cloud IDPs. So most of the people even reach out to us. They come with complex requirements that cannot be accommodated at the cloud vendors. The other approach is, so even now we are working with one large customer in US in the healthcare domain. They use cloud IDP. They use multiple cloud IDPs, right? They use Azure B2C, Azure AD, and other cloud IDPs. Their customers can also bring in different cloud IDPs or any IDP, but they use identity server on-prem as a bridge, right? So all the applications, they trust this central IDP, which is an identity bridge. And identity server will federate to all the external IDPs. Now, if you want to introduce any change, you can do that with the on-prem IDP. For example, let's say you have an application which needs full name. This is a very straightforward example, simple example. You need to have full name as a claim, right? But now you integrate with Azure B2C, it doesn't support full name, right? So it may bring in first name and last name in claims. Now, if you want to accept that, what Azure provides, then you need to do some change in your application code, right? But when you have identity server in the middle, identity server can get the first name and last name, concatenate those together, and create the full name and send to the application. You don't need to do any change. And your application may support OpenID Connect, right? You may need to connect to a partner IDP which supports SAML. That identity server can do the bridging. It knows how to do transformation. Same for roles, claims, and any sort of transformations you can do with IDP. You get more control and also access control, right? So you need to do certain access control, which also relies on your business data, right? So you don't need to expose all your business data to cloud, right? So any users can come from any IDP, but identity server, when it issues a token to these applications, it will connect to these business systems and it applies its own access control policies and make a decision and pass a token. So all the applications, they only know about trust the central IDP, then identity server can seamlessly talk to external IDP. So basically, rather than creating point-to-point connections, we create a bridge. So that's a common, like we see a lot of tendency, like people going, even they use external IDPs, they can use identity bridge to do just passive authentication. There won't be any users in this passive the IDP, but it's acting as a bridge, which knows how to transform tokens and mediate between different protocols. It gives you more control.
Perfect.
It's like a hybrid solution.
Thank you. Thank you.
Hi, Prabath. So I have another question here. Like, have you ever evaluated open source tool like Gravity for access management? Have you got any chance to evaluate that? Yeah, it's an open source tool that we currently use in our applications for access management.
Okay. No.
So it has a backend capability to connect to the identity providers that you said just now.
Okay. I haven't checked that yet.
Okay.
Srikanth.
Yeah. Thank you, Joseph. I think we have had many questions, and Prabath, you could be able to answer. So I think before concluding this, what I'm saying is that this is another fantastic NFJS session which we have today, and I'm mindful that there are core technical members, and we have techno-functional, and there are functional members also attending this session. So The good thing what I've seen is that Prabhat, is that the way you have explained is very, very simple and simple diagrams which you used and explained the core topic. And nowadays is more hot topic is about a discussion on microservice and monetizing those services, domain-driven architecture in PDD, and as well as on Relief Family, we are also very eagerly and very actively working on similar kind of environment. What I'm sure that most of our members who was attending the session could able to enjoy and understand many of those aspects specifically to the security protocols, what kind of an authorization mechanisms, and how specifically on the data residency. Because I would see that whether we need to keep it in the cloud, and then many of these security concerns on the compliance, and many of those country-specific regulations on the data maintenance, etc., is one of the concern. Thank you once again, and thank you all of you from PDD and from Lulu family for spending time. And Prabath, thank you once again. It's a fantastic and wonderful session. Thank you very much.
Yeah, so once again, yes, thanks a lot for giving me this opportunity to do this talk, and then thanks a lot for all the questions. I really enjoyed that. Thank you very much. Yeah.
But wish you all the best for the next book. We have a lot of fans of yours around, and we start most of the things from your book as well. So we owe you a lot. Thank you.
Thank you guys. Bye.
Thank you, Prabath. Bye-bye.
Thank you. Bye, guys.
Thank you.